Let us consider these 2 points in the form of question number 7 and 8. Carbohydrates, under which we can think of aldehexoses and ketohexoses. Now, one example of an aldehexose. Aldehexose means a carbohydrate containing an aldehyde group and 6 carbon atoms in this chain. If a keto group is present, then again that molecule containing 6 carbons means it will be a ketohexose. Now, for example, this is the glucose molecule. Glucose is a typical example of an aldehexose. Now, you can notice an aldehyde group, and this molecule contains 5 hydroxyl groups also. And actually 5 hydroxyl groups are present. These are explained on the basis of the reactions of glucose forming the pentaacidate derivatives and so on. And from the reactions of this glucose, one can come to the conclusion that it answers test for the aldehyde group. Now, this linear structure is also considered in the form of a ring structure like this. In this ring structure, carbon number 1 and carbon number 5 are involved. Carbon number 1 and carbon number 5. Between these 2 carbons, a glycosidic linkage is formed. Now, from here OH, that O is considered here, that H is taken over to carbon number 1, so that it becomes CHOH. Now, since this hydrogen is attached here, there are 2 possibilities. That is, at carbon number 1, in one isomer the OH is on the right hand side, and in the second this OH is on the left hand side. Except this difference, at carbon number 1 configuration, all the rest will be similar in these 2 cases. And so, if you consider 2 ring structures in which the configuration at C1 will be different in these 2 cases, and so one is the alpha glucose, another is the beta glucose, and in these alpha and beta glucose isomers, the only difference is the difference in the configuration of C1. And so, if the configuration is different at carbon number 1, the rest being the same in these 2 cases, we find that these 2 are known as anomers. So, in the case of anomers, you think of 2 ring structures then the difference lies in the fact that the configuration around C1 is different. That is, here OH lying on the right hand side and here OH lying on the left hand side. So these two are known as anomers. All right. Consider question number 8. Now in this case, again I have considered two aldohexoses. But by looking at these two, you can notice that there is a difference among these two. And it is quite obvious. In question number 7, I have considered this carbohydrate, namely glucose. The same glucose I have written here. This is glucose. But this second compound differs again in one aspect. What is that aspect? Of course, by looking at these two, up to this, both are similar. If you come to carbon number 2, again we notice between these two we find a difference in the configuration of the second carbon, not the first one, as in the case of these two. If you have two ring structures differing in configuration around carbon number 1, these are known as anomers. But if you consider these two molecules, one is glucose and the second one is, this is mannose. We consider two aldohexoses. Both of them are aldohexoses containing 6 carbons and one aldehyde group. But the difference lies in the configuration around carbon number 2. In glucose, you can notice around C2, OH lies on the right hand side. But in the case of mannose, you notice around the second carbon, OH group lies on the left. So, if the configuration around the second carbon atom is different, like glucose, mannose cases, then these two are known as epimers. So, in the case of epimers, as we have seen glucose and mannose example, the difference between these two, the molecular formula will be the same, but structurally we find a difference, and that too a difference in the configuration of the second carbon. Numbering is like this: 1, 2, 3, 4, 5, 6 in both cases. And you can notice the difference between these two, glucose and mannose, is the configuration around the second carbon. OH lying on the left side in mannose, and in glucose it lies on the right hand side. So you can notice the difference. Alpha and beta forms of glucose, they differ as far as the configuration around carbon number 1 is concerned. So configuration around carbon number 1, if it is different, we call them as anomers, as in the case of alpha and beta forms of glucose. But as in the case of glucose and mannose, in which the configuration is different, not around carbon number 1, but around carbon number 2. Therefore, glucose and mannose, in which the configuration around the second carbon is different, these are known as epimers. Do you follow? So, a difference in C1 and a difference in C2.